Hi, hello everybody. Hope you're having a nice time. This is Jimo, and today I will be presenting to you one of the simplest topics in our secondary school, and that is indices. Just before we go, let's look at this simple introduction, and here I mean the definitions. Now let's take a look at this number one. We have a multiplied by a equals a raised to power 2. The meaning here is that this a is ordinarily raised to power 1, and this a is also raised to power 1. Going to the second one, you see a times a times a equals a raised to power 3, and you have a times a times a times a equals a raised to power 4. Now a good look at this number 3 shows 4 a's, and we have a raised to power 4. We can take our definition from here. From the above example, in indices we call a the base, while 4 is called either the power, the exponent, or the index. Just take note of this. I would also like to say that you should keep in mind the definition of index. Index is a number or a letter placed at the upper right of another number or a letter that we normally call the base, and this is just to show how many times the base is to be used as a factor. Now let's take a look at this. This is 8. 8 is the same thing as 2 times 2 times 2, and this is 2 raised to power 3. And 9 is also 3 times 3, 3 raised to power 2. 64 is 4 times 4 times 4, and this is equals to 4 raised to power 3. Please note that the word indices is the plural of index. Now let's go straight ahead to basic laws of indices. The general laws are as follows. Law number 1, and I put here 2.1. If you have a raised to power m times a raised to power n, it is equals to a raised to power m plus n. You just add the exponents. When you see multiplication, just add the exponents, and this is provided the bases are the same. So that is why it should be noted here that the bases are the same, but the exponents are different. When you have two or more different bases of the same exponents, you can also multiply them. And how do you do that? You have two different bases here, a and b, but the exponents are the same. Just factorize the exponents, and it's equals to a times b raised to power n. That is the second law. Now for two different bases, you can perform division. and if you have a raised to power n divided by b raised to power n, all you do is to factorize and you still have a raised to power n, everything in brackets raised to power n. This is the third law. Please write this as we go along. However, if the exponents in equation 2.3, that's this law here, if the exponents are different but the bases are the same, then a raised to power m over a raised to power n is equals to a m minus n. The meaning here is that if you have division, the same base but different exponents, you just need to subtract them. So multiplication is addition, division is subtraction. Take note of that. Let's take some examples. Now this example is telling you that with just those 4 laws, you are ripe enough to solve SSCE questions. Let's look at this NECO SSCE in 2003. The question is just simplify x raised to power 0, x raised to power minus 2, x raised to power 3 divided by x raised to power 5. The first thing that you should keep in mind here is that if you have 2 letters that are written together in mathematics, they are multiplying each other. For instance, s raised to power 0 is multiplying s raised to power minus 2, and s raised to power minus 2 is multiplying s raised to power minus 3. So how do we solve this? The first thing is just to rearrange this question, put it in this form. This division becomes over. Then let's recall the first law. The first law says if you have 2 or more base but they are all the same, like x, so you just pick one of them and just add the exponents. So you have 0 plus minus 2 plus 3 divided by x raised to power minus 5. This is equals to, if you had the whole of what you have here, you have x raised to power 1, and this is still s raised to power minus 5. Now we recall law 2.4, that is division is minus, so you have 1 minus minus 5, and that will be equals to x raised to power 1 plus 5 and x raised to power 6. That is all. You have 1 point. Let's look at another example. This time we are taking from UME, what is presently called UTME. Let's look at this. Simplify f raised to power half, g raised to power 2, h raised to power 1 over 3, all divided by f raised to power 5 over 2, g raised to power 0, h raised to power 7 over 3. So how do we go about this one? So what you're gonna do is to change this division to this form and just put like terms together. We have f raised to power half, g raised to power 2, h raised to power 1 over 3, f raised to power 5 over 2, g raised to power 0. is just repeating all I have here. Now we put the like terms together. Put all the f's together, all the g together, and all the h together. So you have f raised to power half over f, g also over g, and h all over h. Now begin to apply appropriate laws. So from 2.4, when you have division, it means you are going to subtract. So that's why we have half minus 5 over 2 times g 2 minus 0 and times h 1 over 3 minus 7 over 3. So what do you have? When you subtract half from 5 over 2, you get this. 2 minus 0, get this one. 1 over 3 minus 7 over 3, you get this one. I must say here that in JAMB you need to be fast. So since you have the denominator to be equal here, all you need to do is just subtract the numerator from one another. I mean 1 minus 5 is minus 4, so it's going to be minus 4 over 2. 2 minus 0, this is also 3, denominator, and 7 is also 3, so you just subtract 1 from 7 and take one of the 3's, so you have minus 6 over 3. So at the end you're gonna have something like this, and you can rearrange. Remember, this one, if it comes down, it becomes positive, that is from 2.4, and also h raised to power minus 2 become h raised to power 2, and from 2.3 you can put all of them in a bracket since they all have the same exponents, and that is your answer. So could you just try your hand on this one? Simplify. This is WASC 1993, question number 7, and your answer is this. Please just try and try your skill on this one, and let's see if you are going to get the answer in 5 minutes. So in our next meeting we are going to continue with some of other laws, and we see how we can apply them to solve more questions. Bye.